All right. Hey guys, before we get started today, go grab a pen or pencil, paper, something to write on, and a calculator so you can participate in this. Again, I encourage you to pause the video at any time and try to work it out, get ahead of me, and then play it and see if you did it right, just like we would do in class. So today we're going to look at surface area of a pyramid. So I've got a pyramid right here. A pyramid has 5 faces. It's got the bottom, and some pyramids have square bases. Some pyramids have rectangle bases. Some pyramids even have triangle bases, and I think those are called tetrahedrons or something different. But anyway, so this in particular one is a square-based pyramid. Okay, it has 5 faces: 1, 2, 3, 4, 5. This that goes straight up. This is what we actually call the apex. This distance from the base straight up the middle of the pyramid would be like its actual height. Today I'll be talking about slant height, and slant height is this height right here. So we have a triangle right here. If I could tip this triangle up on end, I would need to know the slant height to know how tall this triangle is. Okay, because we're going to be finding the area of each of these faces. An area of a triangle is base times height divided by 2, and this triangle's slant height would be its height that we would need. Okay, so let's look at this first one. The area of the bottom, it's a square, so it's 6 by 6. So we'll do that one first because that's the easy one. So bottom is going to have an area of 36. Okay? Okay, now this face over here, actually all of these triangle faces are going to be the same because it's a square base. Okay? So this would be base times height. This has a slant height of 5. So 6 times 5 is 30, divided by 2 is going to be 15. So this triangle has an area of 15, this triangle has an area of 15, the one over here has an area of 15, and the one in the back has an area of 15. And we add all of those up. 15 and 15 is 30, 60, 60 plus 36, that would be 96 meters squared. Okay? All right, so that one, all of the triangle faces were exactly the same because we have a square base, okay? This is very doable as long as we're given the slant height. But what if we're not given the slant height? Let's say that we weren't given this number right here. We didn't know that that was 5. Instead, we were maybe given the height, the actual height of this pyramid. And let's say that that actual height of the pyramid is 4, okay? We would need to figure the slant height. Like, we've got to know the slant height to find surface area of a pyramid. So I want to draw your attention to this imaginary right triangle that's formed right here. And I don't know how great my drawing is or how great you can see it. I did share one more video link on here that had a little bit better drawings than what I can do. Let me try to push this towards you a little bit. So I've got an imaginary right triangle drawn in there, okay? So if we weren't given the slant height, we would need to bring Pythagoras back, okay? This whole line right here is 6, so that means this line right here would be 3. And that is, the slant height is the missing hypotenuse. So I would do 3 squared plus 4 squared equals the hypotenuse squared. So 9 plus 16 equals the hypotenuse squared. 25 equals the hypotenuse squared. Square root both sides. So the hypotenuse is 5. So if you're not given the slant height, that means they probably gave you the actual height, and you would need to use Pythagorean theorem to find the slant height. Okay? We're going to look at one here. I've got one more for us, and then there's that extra video link if you want to go look at it. Okay. Okay, so this one I was super mean to us, and I didn't make it be a square base. I purposely made it be a rectangle base, okay? So that means the slant height over here and the slant height here are going to be different because this is not a square this time, okay? So we're going to have to use Pythagorean theorem a couple of times. All right, so let's look at, well, let's do the area of the bottom. That's the easy one. So the area of the bottom is just a rectangle, 8 by 4. That's 32 meters squared. All right, we can handle that one, okay? Let's look at this one over here. I think that's the easier one to see. Okay, so this leg down here, if this is 8, then this leg is going to be 4. So to find this slant height right here, we're going to have to do 4 squared plus 6 squared equals the hypotenuse squared. 16 plus 36 equals the hypotenuse squared. 52 equals the hypotenuse squared. Kind of miss having you guys in class to double check my mental math. Sometimes you know how I am. My mental math goes a little crazy. So, okay, so we need to find the square root of 52. And I got, if I round that, I get 7.2. I'm going to go with 7.2. So this slant height right here is 7.2. And that would be the same for this back side over here. But this one that's looking right at us is going to be a little bit different. So if I imagine this right triangle, and here's this slant height coming at me, it's coming towards me. Here's the right angle right here. This length right here, if this is 4, then this leg right here is going to be 2. So now that one, we would do 2 squared plus 6 squared equals the hypotenuse squared. So 4 plus 36 equals h squared. 40 equals h squared. So I need to do the square root of 40. Punch that in. I'm sure it's not going to be pretty. I'm going to round that to 6.3. Okay. So this slant height here is 6.3. Okay. All right. Now we can go. Okay. So this triangle has a base of 4 and a height of 7.2. So 4 times 7.2. It's a triangle, so I'm going to divide by 2. I got 14.4. So the base, 14.4 for the right side, 14.4 for the left side. Now I've got this front. The base is 8. The height is 6.3. I'm going to divide that by 2. I got 25.2 for the front and 25.2 for the back. And I'm still on there. Okay. And so then I just add those up. So I've got 25.2 plus 25.2 plus 14.4 plus 14.4 plus 32. And I ended up with 111.2 meters squared. All right, I encourage you to go watch these again or watch that other video. He's kind of got a little bit better drawings than I do. So if you want to listen to somebody else do it, feel free to do that and go back and watch this one. Okay, good luck.